This is physics moving into Unit 5. We're talking about astronomy, space, and gravity. The first science was probably astronomy. The Greeks and Egyptians studied the heavens from the frame of reference of the Earth. So from the frame of reference of the Earth, they observed these things, and so can you. Their first observation: the sun orbits the Earth daily. The sun rises and sets at different times and places each day. In the summer, the sun rises to the north of east and sets to the north of west. In the winter, the sun rises to the south of east and to the south of west. The sun rises most directly in the east and sets most directly in the west in the fall and spring. The sun rises much earlier in the summer and sets much later in the winter. The sun's altitude, or its angle above the horizon at noon, varies from season to season. Now, we need to define noon because the astronomy definition of noon is not exactly the same as our typical definition of noon. An astronomer's definition of noon is when the sun is at its greatest altitude. Noon happens when shadows point directly north. And this is, of course, for the northern hemisphere only. Or a third one, you could say that noon is halfway between sunrise and sunset. So since this is a video, you can't really see me pointing. So point to the sun today at noon. And so I am pointing south, and the angle that I'm pointing is probably about like this. Tomorrow at noon, of course, we're in the late fall, so it's going to be slightly smaller of an angle here. So if I'm pointing to where the sun is at noon on December 22nd, which is the shortest day of the year, I am pointing at a very small angle here. Where is it at June 21st at noon? I'm pointing almost directly up. Of course, this far north in the northern hemisphere, the sun is still going to be a little bit south of us, but it is pretty high up there. I actually have some numbers for you, so just off in the margin, the sun's noon altitude. And this is specifically for Carroll County. June 21st is 73 degrees. That would be this one. September 23rd, the equinox, 49.5 degrees. So we're just past that by maybe a month or so. And so if it was 49.5 in September, we're probably looking at something like these. On December 22nd, the angle is 26 degrees. The altitude of the sun at noon is 26 degrees, something like this one right here. And on March 21st, the other equinox, we are back up to 49.5 degrees. So here's a question for you. Is noon necessarily 12 o'clock? The answer, no. And so why not? And it has to do with the width of the time zones. Indiana is on Eastern time. We are at the very west side of the Eastern time zone. It gets dark here. A couple days ago when I checked, the sunset was at 5:30 p.m. But the Eastern time zone is so wide that on the far east side of it, like New York City, they're getting dark closer to 4:30. And so these time zones are so wide that noon is not necessarily going to be 12 o'clock. Is noon at 12 o'clock for anyone? Yes. Could be. Maybe the middle of the time zone? Question mark. But again, not necessarily. Depends. The next observation, from the reference of the Earth, the moon orbits the Earth daily. The moon rises and sets at different times each day, rising about 1 hour later each day than the day before. The moon appears differently to us over the period of a month. So let's look at the phases of the moon here. And so I've got this diagram. It is very much not to scale. On the far left side, we have the sun. Here's the Earth, and here's the moon. Now, the Earth and the moon have some distance between them. The moon is not halfway to the sun. In fact, in this picture, if the Earth is here and the moon is here, where should the sun be? Is it maybe out by the football fields? Maybe, actually, not really. It might be somewhere in Burlington. And so that's the sort of scale we're talking about here. So my scale is very far off on this picture. We're going to go through the phases of the moon. So here we have the sun, the moon in the middle, and we are here on the Earth. Now, during a new moon, if we look up in the sky, the only thing we can see is the dark side. So what do we see during a new moon? We really don't see anything. It's dark. You might say that there is no moon. And the moon rises at sunrise. So not only are we seeing the dark side, but it's only visible. We can only see it during the day, and so that's what's making it difficult. And so the moon is orbiting the Earth. And now it's here. This is approximately 7 days later. And so what do we have? What are we going to see? So here we are, the Earth is spinning this way, and now we can see it. We see this half of the moon, the other half of the moon is dark. We see a half circle. What time does the moon appear to rise? So here we are going around, and I guess if we wanted to be very specific, this is going to be the dark side of the Earth. And so here it is spinning, and now it's morning. I can't see it, I can't see it, I can't see it. Here we are. This is the first point where I'd be able to look over and see the moon. Halfway between sunrise and sunset. The moon rises at noon. This is what's known as a first quarter moon. So we see a half circle. The moon continues to go around the Earth, and here it is, approximately 7 days later. What do we see? So if someone on the Earth at night is looking up, they are seeing an entire circle. This is the full moon. We see a full circle. And what time does the moon appear to rise? So here we are going around. We can't see it, we can't see it, we can't see it, can't see it. This is sunset. This is the first point where I'm able to look up and see it. It's going to be visible all night until here it is. This is sunrise, and that's the point where the Earth itself is going to start getting in the way from us seeing it. So during a full moon, you would not see it from here because the Earth itself is blocking. Moon continues to orbit the Earth, and about 7 days later, here is the moon. We call this the third quarter. What time does the moon appear to rise? So going around, can't see the moon, can't see the moon. There's sunset, still can't see it. Going around. This is probably the first point where we're able to look up and see the moon because the Earth itself is no longer blocking us. Halfway between sunset and sunrise. Moon rises at midnight. And then it continues to rotate to orbit the Earth, and about 7 days later, approximately, we're back to the new moon. So the moon is going around. Also at the same time, the Earth itself is spinning, And if we're looking down, and if this were the North Pole, the Earth would really be spinning this way. And it's also orbiting the sun. You don't have to draw all of this, but the Earth is moving this way. So there is a lot of motion going on here. And other observations made by the Greeks and the Romans is that the seasons vary in length. Spring goes from March 21st to June 21st. It's 92 days. Summer starts June 21st and ends September 23rd. This is 94 days. Fall September 23rd to December 22nd, 90 days. And the winter, December 22nd to March 21st, 89 days. Why these dates? Well, let's look at the significance of these dates. The first one being March 21st, and this date is called the vernal equinox. Vernal meaning green, and equinox referring to the sun being directly above the equator. June 21st, we have the summer solstice. This is when the sun is directly above its most northern point on the Earth. This is the edge of what we would call the tropics. September 23rd is the autumnal equinox. And at this point, the sun is now rising more and more in the south every day. This is directly above the equator. And the days continue to get shorter. The sun becomes further and further in the southern hemisphere. December 22nd is the winter solstice. This is when the sun is at its southernmost point in the sky. So why these dates? The sun is above the equator, March 21st and September 23rd, the equinoxes. The sun is above the Tropic of Cancer in the northern hemisphere on June 21st, and the sun is above the Tropic of Capricorn in the south on December 22nd. The next observation, the stars rotate daily around the North Star. The stars have remained fairly stable over the centuries and thus provide a good coordinate system. It works well for locating objects in the sky. We often refer to an object's position relative to the background of stars. In order to understand the celestial coordinate system, we need to first understand Earth's terrestrial latitude. latitude lines run east-west around the Earth and measure your position north or south of the zero position of the equator. It varies from 0 degrees on the equator to 90 degrees north at the North Pole, and to 90 degrees south at the South Pole. Carroll County's latitude is about 40.5. In terms of actual numbers, 40 degrees, 31 minutes, 50 seconds, let's say north. And so just to describe what these symbols mean, 1 degree is 60 minutes. You'd say 1 degree is 60, 1 apostrophe. 1 minute is 60 seconds, or one, try that again. "40 degrees, 31 minutes, 50 seconds north." As far as our terrestrial longitude, longitude lines run north-south. North-south around the Earth, and they measure your position east or west of the zero position, which is known as the prime meridian, which runs through Greenwich, England. It varies from 0 degrees to 180 degrees west or 180 degrees east. The position of 180 degrees longitude is called the international dateline. Carroll County's longitude is about 86.5 degrees. More accurate number, 86 degrees, 29 minutes, 40 seconds, and that's west. So now back to our celestial coordinate system. The Greek system is called a geocentric system. Geocentric, because the Earth is at the center. All of the stars are assumed to be the same distance from Earth, thus forming a sphere of stars. The Earth's equator is projected outward onto this bubble of stars, forming the celestial equator. So let's look at it like this. So here's the Earth, here's the equator. Say this is the equator, and so it is just projected outward into space. That is the celestial equator. Celestial latitude is a measure of an object's position north or south of this zero line. Celestial latitude is a measure of an object's position east or west of the zero position. The zero position is known as the vernal equinox. When you look back up at the top, you've seen that term. The vernal equinox is the sun's position against the background of stars on March 21st. So a note, you're going to get a paper when you come back. It is the planetary longitude chart. We'll talk about this again when you get it. But the JD date refers to the Julian date, the Julian calendar. And it is a consecutive day calendar which assigns day 1 to a date in 4713 BC. And so on our chart, all of these dates are missing the numbers 244 in front of them. So whatever the Julian date is that you're looking at, it should have a 244 in front of that. The planets orbit the Earth daily. Planets were first called wandering stars. The word planet actually means wanderer. So they're called wandering stars because with the naked eye they look like stars, but they move against the background of stars. Remember, the background of stars remains the same. These planets are wandering against them. At times, they even appear to move backwards relative to the stars. A motion known as retrograde motion. And we'll check the planetary longitude chart for that as well. The 9 planets in our solar system, and this is kind of old because the definition of a planet changed maybe 10 or 15 years ago, and this was never changed with it. So Pluto is no longer in this list. So let's go ahead and write the old 9. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and in parentheses, Pluto. Now, the reason Pluto was demoted and it's now classified as a dwarf planet is because before about 10 or 15 years ago, there was not actually a definition of what is a planet, which was about to get really convoluted because we were discovering lots of things orbiting the sun that we hadn't seen before. And so scientists came together and said, how can we define a planet? So the first piece of the definition is that the planet orbits the sun. So the moon is not a planet because it orbits the Earth. So it has to be something that orbits the sun. And the second piece of criteria was that it had to have enough gravity in order to clear out all of the stuff in its orbit. So Earth doesn't crash into things in its normal orbit because it's been here long enough that anything that was in its orbit is probably a part of the Earth or the moon or was launched into space because of gravity. And so these planets all fit into that category because they cleared out their orbit. But Pluto is out in this area where there's just so much junk in its orbit that it didn't clear it out. And so it didn't fit the new definition of planet. And so that's why it is now a dwarf planet. So we're going to underline the ones that are visible to the naked eye, both to the Greeks and to us today. Venus, Mars, Jupiter, Saturn. Now, I'm not going to underline the Earth. We're on the Earth. We can see the Earth. We cannot see Earth in space from our frame of reference on the Earth. We can see Venus. We can see Mars, Jupiter, and Saturn. Mercury is small and very close to the sun. Uranus and Neptune are both so far away that they don't really reflect enough light. Even with a telescope, it has to be pretty powerful. Pluto, you would need a very strong telescope, and even then it looks like a dot. It took astronomers a long time to find Pluto.